UMIS. Tapi UMIS sekarang dah tak ada kan, dah tutup lah. Sekarang Manchester University dah. It was long back in 1995 lah. And I'm also the professional engineer with Board of Engineers Malaysia, and also chartered engineer with ECUK. Okay. Work experiences, I've started my career with a consultant company. I've been involved in KLCC project. So gambar ni masa sebelum KLCC di apa commission kan, and so kita bolehlah naik atas dekat pinnacle tu. So adalah peluang ambil gambar kat atas tu lah. So ini during this time I did a building services, M&E building services, involved in the outfitting of KLCC. Then I moved to PSC Naval Dockyard in Lumut. This is where I gain knowledge about marine system, especially warship design. So I've encountered several odd voltages and frequency. For example, in our building, in our onshore facilities, we have 415 volt, three-phase 50 hertz. But now on the marine vessel or warships, we have 440 volt, three-phase and 60 hertz. And also for the 400 hertz system, for the weaponry system, we have also 120 volt with a three-phase system. So this gives a different exposure to me in terms of marine system. Then I moved to another company, another consultant company, also involved in the building services, where we built military camp in Gemas, Negeri Sembilan. At this consultant, I was the resident engineer, located at site in Gemas and responsible for the target system. Then I moved my career to Grand Bank Yachts in Pasir Gudang. Again, another exposure. This boat is actually a 12 volt DC system. So new experience as well. My oil and gas experience started with Bumi Armada, where I did FPSO project in Bumi Armada. As you know, Bumi Armada is actually the operator of FPSO. Then I moved to SBM, also another FPSO operator. In this company, I've designed the system for KK FPSO. There are some modification where they tie the Siakap North Petai to the existing KK FPSO. Next, in Acre Solution, I was involved with FPSO Chendor project as a consultant instead of operator side. Then I moved to Technique. We have completed Malikai project with Technique. Then again, I moved to MIC, also the operator of FPSO. Next move, I joined ETAP Automations. This ETAP is actually a software company where they provide the software for power system analysis. Over here, my responsibility was different from previous companies where I was responsible for the business development part of ETAP in Malaysia. Now, having spent about 2 years in ETAP, there was an opportunity to do a Petrobras project with Rehin Wali. Then I joined Rehin Wali for the P82 project. This project is still ongoing, but we have completed the electrical part of it. In my current company, I'm working with Sapuji Palonji. This is a Indian company. They are also FPSO operators. They've just commissioned this Armada Sterling 5, and at the office we are supporting the operation of this FPSO at the moment. So this is my current position as a HOD for electrical. Okay, this is a brief introduction about myself. Okay. Any questions?
All right, perfect. Okay, Marin, it's really interesting to see all your experience. So I guess, Marin, we can started with the training straight away.
Okay, so we go to the training straight away. I will share my screen. Just hold on.
By the way, I left your slide just now. Something.
Right, thank you. Hold on. Okay, is it okay now? Can you
Yep,
see?
fantastic.
All right, good. So today we are going to discuss about induction motor. It is actually a three-phase induction motor for non-electrical engineers. So before we start, I would like to give a context of this training. I assume that most of the audience here are non-electrical engineers, right? But you are using motors to drive your processes. For example, pumps and compressor. And there are many types of motors. For example, DC motors. We have shunt motors, compound motors, and a single phase induction motors as well. But in our training today, we are going to concentrate on the three-phase AC induction motor only. Okay, and then also the objective of this training is to get to explain the functions and roles and responsibility of electrical engineers to help the package responsibility engineers in the oil and gas setup. We have mechanical engineers as PRE, which is the package responsibility engineers, who are coordinating all these package documents and drawings, and then distributed to electrical engineers. So by understanding how this three-phase AC induction motor works, it gives a better understanding between the mechanical engineers and electrical engineers that are responsible for the package reviews. Okay, and we as electrical engineers, we have two responsibilities. One is to review the package under PRE. Then the other electrical engineers need to provide the services in terms of power requirements to the motor. Okay, And then we also need to make sure that the supply that we provided to run the process will not be affected by the quality of the supply in terms of voltage and frequency. So as such, we need to do lots of studies, simulations, analysis, to make sure that there is no downtime in the process. Why is it important for us to understand the induction motor? It is because it is widely been used by the process, HVAC system, and lift, and many more. So they are these induction motors are very easy to control. That means in its simplest form, you can control it. You can start it by direct online method. That is uh, the very simple method of starting the motors. We will look into this type of starting later in the training. And unlike gas turbine driven pumps and compressors, uh, we do not have no auxiliaries of like GTs, where you need to before you run the main pump by gas turbine, you need to run its auxiliaries. So for induction electrical motors, it is very simple. You just provide the voltage to the motors and it runs. And also, since most of the process equipment are motors, we need to understand the working principle of induction motors so that we can have very efficient in terms of energy requirement. For motors, we have four efficiency class by IEC. We have IE1, that is the standard efficiency. We have IE2 for high efficient motors, IE3 for the premium efficiencies, and IE4 for super premium efficiencies. Um, these motor efficiencies are tied to the commercial. If you are looking for highly efficient motors, that means you need to pay more. And then normally we go for standard efficiencies. But it depends on the project's requirement. So it is important to understand that all components that make up the motors, and from there, we can develop a good preventive maintenance for the audience that involved with maintenance of a plant. Then in the end, it will lead to reduce operational costs, and then finally, it will result in overall cost saving. By default, induction motors is a robust machine, and knowing components that make up the motors and how they are interacting with each other give us a good understanding where the potential issues may lie and effectively tackle it before it becomes a major problem. Most of the issues with motors are vibration, bearing failure, especially the sleeve bearings motors. We will look into it in detail after this. And then you need to carry out the maintenance program to ensure that the motor can run without any issues. So understanding the induction motor is important for uh, audience that involved in the maintenance of the plant. The other important of understanding this induction motor is most of the time the mechanical engineers, the PRE, uh, are the one that coordinating all this vendor data review that is passed to electrical engineers. But now, if the PRE understand the induction motors, then he could be the first pass a reviewer before it comes to electrical engineers. So by doing that, the PRE will have the same understanding with electrical engineers, so that the process of reviewing the vendor data can be smooth. The next importance of understanding induction motor is understanding various way in which it can be controlled and started. And having understand this, we can employ the more advanced solutions and give a wider operating range for the driving equipment to operate. For example, the um, direct online motors compared with VFDs. VFDs will give you more wider operation range in terms of process. But for the direct online starter, it will give you a fixed speed, and then there is no way you can control um, the flow or the pressure of the compressors or motors. So understanding of this induction motor is important in terms of controlling the um, plant. Now, in terms of safety, um, you will understand that motors are really good when they are running cool. If the heat rise is very high, then it affects the longevity of the motors. So by understanding that it has to be run cool, we can take precautions in terms of getting the the ventilations to the motors, so that the motors can run efficiently. In terms of environmental impact, many clients prefers to have induction motors instead of gas turbine driven compressors or pumps. The induction motor gives never emits any greenhouse gases to the environment, so it is a good choice for the environment. So engineers often need to diagnose and fix issues related to motor. So the a good understanding of induction motor aids in effective troubleshooting and problem resolution. Now, as I explained just now, mechanical engineers as a package responsibility engineers, the focal point of both pumps and motors vendor review. So on motor side, what is required by electrical engineers? For example, the torque, current versus speed characteristic is known to PRE. Then the process of vendor data review will be more effective if the PRE understand how the induction motor works. So we will discuss this in detail later in the training. Now let's look at the three-phase AC induction motor components. Now this shows the blowout illustration of LV three-phase AC induction motors. We have a drive end. By the way, this what shown here is the LV motors. And then number two, we have a terminal box. And also we have a rating plate. In addition to this stator components, we have a rotor. Then at the end of non-drive end, we have fans and fan cover. Then we have a terminal box cover, bearing, and non-drive end. So normally, induction motors are divided into two. One is the LV, which is the low voltage motors. The other one is HV motors. That is high voltage motors. LV motor voltage will be 400 volt and 415 volt. And then according to the IEC, HV motors will be the ones that have greater than 1000 volt. In normal case, we could have 3.3 kilovolt motors, 6.6, 11 kV, and the maximum available motors that we have in the market is 13.8. Okay, this shows another picture of motors. It clearly shows you the stator winding and the rotor, and in between there are bearings of the motor. Next is another illustration. It is the cross-sectional area of LV three-phase induction motor. So far, is there any question? The question sih, tak ada.
From chat box belum ada lagi. Tapi kalau from my personal question, apa beza induction dengan non-induction Cik Barin?
We have I will explain to you lah the next slide because I've prepared some practical things for audience to do as well. Then from there I will explain what is the why is it called induction.
Okay. Alright, fantastic. Mungkin boleh include sekali kot what's the difference between AC dengan DC punya induction motor, boleh ke?
At the moment I'm preparing only on the AC induction motor, but I have not prepared for the DC motors yet. Yeah? Because the objective is to most of the motors in our process plant are the AC induction motors. So rarely we have DC motors.
Alright, baik.
Okay. I would like to go into the anatomy of AC induction motors. If you see here, we have a stator core which have got 24 slots. Okay, and then these 24 slots, it will become a four-pole motors. We'll see later how this come about. Now, given you this stator coils or stator core, then the next item that you need to prepare is the winding. The best thing is to prepare the winding. There are several hundred turns. The more the turns, it will result stronger magnetic field for the motors. That means the motor will be powerful. The copper that you saw in this picture are made of copper with enamel coated, so that it will be insulated from the other coils that we are going to wind. Okay.
Cik Barin, ada satu soalan from chat box dari Cik Amil. How to choose motor number of pole for our application?
Okay, normally for applications, the vendor, no, the process is actually like this. Since you are the process engineer, you know better. You will size the process, and then you will determine what are the absorbed powers of motors or compressors, right?
Yep.
Then from there you will know the the flow.
Yep.
With that flow, you'll give to the vendors, and then vendor will size the the motor accordingly. And then from there, it will determine whether you need to have very fast RPM,
Mm-hmm.
or you can work within 1500 or 1800. Now, if you are going for faster RPM, that means you need to go for two poles. We will look later in the training where how this comes about. But for this, to answer these questions, um, the pole,
Mm-hmm.
two pole motors run faster than the four pole motors.
Oh,
So for us, it will depends on the vendor. It will depends on the applications of the uh, plant, whether you need to have a higher RPM or lower RPM. And then accordingly, if they need the lower RPM, then we can go for four pole motors or less than that. But for the higher RPM, we have to go to two pole motors.
alright, understood. And kalau Cik Bahari tengok on the previous slide, ada one of the participant tanya through the chat box. Dia tanya, why is the stator core built like that, a hollow cylinder? How does the stator core relate to rotor and enclosure the induction motor?
Okay. If you see this, this is just a stator core. The
Hmm.
reason of having these slots is actually for us to put in the winding. Okay. We will look later on how to rewind this motor. Then you will understand. Basically, the reason is for induction motor, we want to have uh, basically we want to have a strong magnet. We cannot have permanent magnets mounted on this stator core. So what we will do is we will put the winding. This winding, according to the Maxwell law, um, when we pass the current through this coil, it will create magnetic field. So that magnetic field is not permanent. So it can varies according to the voltage that we supply. Remember, we have got a three-phase supply.
Hmm.
Then each of the phase is actually lagging one and the other. So you will have uh, resultant um, rotating magnetic field in this stator core.
Mm-hmm. Alright, baik.
Is that answer the question? Or later you can see more clearer when we do some practical winding in this training.
Alright. Okay, mungkin
Okay.
Masya kalau ada additional question, you can follow up dekat chat box, I will assist you. And while that, ada additional question coming in, Cik Barin.
Okay,
Uh,
okay, boleh.
is
I like this one, because it is interactive, rather than I'm speaking, I do not know whether people understand or not. So you
yeah.
ask many questions better.
Alright, so I will assist you, Cik Barin, through the chat box. I will moderate the session. So
Okay.
there are new question coming in daripada Cik Amil. So macam this one is because motor is usually the one that will drive the pump. So is the question is coming in for the high viscosity fluid. Is it better you use a high number of pole, or better you make some gearbox amendment at the rotating side to handle the high viscosity fluid, because it's require high torque application, right?
Yeah. Basically, I think Shuib, you can answer that, right? Because it is more on the process, and but for us, if you want to have better controls in terms of high viscosity of fluid that we are pumping,
Mm-hmm.
um, we opt for the VFDs. For the VFDs, when you start, you're at the lower operating point. Then as you require, you can increase the torque to its maximum. But
Mm-hmm.
for the VFD, when you started, of course, for other process also, we'll do the recycling. Instead of you're starting the motors and then you open the valve. So
Mm-hmm.
that will cause the motor to be uh, to have it is unbearable to the motor. So normally we start the motors with valve close.
Mhm.
Now, if you want to have higher starting torque, then you have to go to a direct online method where the full voltage is available at the motors and it will start it off with high torque. But that is more on the control side of it. But for the motors, we will see how the torque is produced, and then the relationship between this torque and voltage, and how VFD is actually controlling the flow or the operating point of the motors. I hope that answer the questions,
Yeah,
because that is more on the process and then selections, by vendor.
Because what I understand the question is macam dia nak tanya pasal during design stage tu, kalau kita proses already identify is require is a continuous high viscosity punya fluid. So so better kita nak gunakan a high number of pole dekat motor side ke, ataupun dekat gearbox dekat pump tu yang kita nak increase the gearbox punya ratio ke something like that. So usually ataupun dia ada balance between both of them, Cik Barin.
Tapi for us, it is not our call tau. It is more on you. A process is process will give the process data to vendor, then vendor will size accordingly.
I see.
Whether
Alright.
they wanted to use VFD or they wanted to use gearbox,
Mhm.
or you don't need to use anything else, just VFDs.
I see. Understood. Okay.
Hmm.
Clear on that. Alang-alang tu ada additional question kami in, tapi it's talking
Bagus.
about the VFD application. So dia nak in relation pasal VFD application specific to power, adakah is it proportional to the speed or the RPM itself? Mungkin dia tanya relationship between the power and the speed untuk VFD application.
Oh, okay. Tak,
Ah,
dia tak ada relations pun, sebab when you size the motors, it is more on the kilowatts, right? And
mhm,
then for the RPM, uh, the range for the RPM is actually from 0 to 60 hertz. For example, the power supply is 60 hertz, then it goes up until 60 hertz.
mhm,
If it is 50 hertz, then it goes up until 50 hertz only lah. But the power is a separate thing. It is not related to the RPM. You have got some powers of the motors, and then also you can control it by varying the speed.
mhm.
Hmm.
Okay, alright. And kalau continue from the question, ditanyalah, why the cubic law only apply to the motor yang ada VFD yang handle centrifugal load but not for linear relationship torque load?
Apa dia? Cubic apa?
Cubic law, is it cubic law, they apply to the motor yang ada VFD yang handle centrifugal load tapi not for linear relation punya torque load. Mungkin saya pun it's a new topic for me. Cik Bari dapat kan?
Hmm.
Kalau tak dapat mungkin saya nak minta tolong Cik Azim untuk unmute, boleh ke? Cik Bari boleh boleh dapat
Boleh,
soalan?
boleh, boleh.
Boleh
Boleh,
eh?
sebab saya pun
Kalau
tak dapat soalan tu.
tak dapat soalan tu, okey. Cik
Ah,
Azim boleh ke saya minta Cik Azim untuk unmute, and maybe it's better if direct tanya terus Cik Azim? Cik Azim Burhan. Boleh? Boleh? Tak apa, jangan menyesal sebab saya minta untuk awak unmute Oh, mic ada problem. So Cik Azim kata dia ada relate to affinity law, Cik Bahri. You have any idea on that?
I tak ni lah, I tak familiar lah.
Okay, alright. It's okay, alright. Kalau macam tu, mungkin kita teruskan. Nanti kalau ada additional punya discussion pada Cik Azim nanti, saya akan continue back the question lah, Cik Barin. So
Okay,
you may
alright.
continue first. Alright.
Okay, tadi kita dah discuss pasal stator core ni, given. Then we prepare for the winding. And then also we prepare for the insulations inside the stator core. Okay. This white material is actually the insulations that we put in between the slots where we are going to put the windings. Okay, now if you see this winding just now, and then if we lay this flat, it will become something like this. Okay, now if we zoom through the winding, the coil that goes, it will go to slot. For example, this. Wait, I'm taking this. If you see the red color winding, it will go from slot number 1, and it comes back to slot number 7. Then it goes back to slot number 12, and it goes round back to slot number 7. So by doing this, we can trace, how the pole of the motor is generated. So now if you compare this, I put the numbers here, number 1, 2, 3, 4, 5, 6, 7, 8 until 24 slots. So when we do the winding, we are going to start from winding number 1. This one winding number 1, no, slot number 1, then it goes back, it goes into slot number 6.
Cik
Okay,
Barin,
from now,
sorry, ada soalan tanya dekat previous page tadi tu, apa dimasukkan UV dengan W?
Okay, UVW. Actually, I have prepared the slides. After this to explain this. This one, this slide, I just go through quickly, so that you understand the concept. Then we'll discuss further on why U1, V1, and W1. Yeah.
Alright, okay, sure.
Okay. Now we have numbered the slots 1 until 24. Then we can start to do the winding lah. Okay. We start to rewind this motor. Just hold on. I'm going to use this.
Sambil-sambil Cik Bahrin tengah setup tu, ada orang tanya, winding tu dia orang pakai tangan ke guna mesin tu Cik Bahrin?
Oh, winding tu dia pakai mesin sebab dia kena wind the copper wire tu it should have more turns lah. So if you go for higher turns, that means the magnetic field will be much higher. So motor tu kan be very powerful lah. Sekejap, I nak share something else.
Okey, Cik Masya lah menjawab soalan. Awak siap bagi smiley lagi. Alamak.
Nampak sekarang cik?
Okay, cantik.
Okay. Sekarang ni, if we trace U1 ni, okay. Dia actually, motor ni adalah dua winding yang tak bertemu tau. Maksudnya, we have winding for example, we take this wires, we have one end. This one is the first end. This one is the second end. Okay. We take these wires and we wind it through the stator slot. Okay. Now if we follow through yang above ni, U1 is actually the first end. Okay. Then the second one, the second end is actually U2. Right? Now what are we going to do with this is actually to wind it. For example, if I take this as a U1, then I follow through, I put in the winding inside, and then it goes all the way at the back, right? Okay. Then it turns, and then it goes inside the slot number 6. Now we have here winding that goes inside, and then at the slot number 6 is coming out. Okay. Now from slot number 6, it goes to slot number 12. Now it goes to slot number 5, it goes inside. Okay. The same thing, if you trace back, then it flows back to slot number 7. So it goes from 12 and then it goes at the back and then it come out at 7. Then from 7, it goes into 13. Yeah, just bear with me. Yeah. Goes to 13.
Right.
Okay. Now from 13, this is why I put this in the flat winding so that we can do this the winding and trace it. Now from 13 it goes to 18. From 13 it goes at the back and then come out here at 13, 18. All right. Then it goes to 13. Come out at the back and then goes to 13. Wait, hold on, sorry.
19.
No, it goes to 19, right? Yeah, 19. No, from from 13 to 18. From 13 to 18, it come out. Then from 18 to 24. From 18, it does not come out here. Sorry. You will understand why I do this here. And then it goes to 24. 24 goes inside. Then from 24, it goes back to 19. So it goes at the back and then it come out here at the 19. So this is U2. Okay. Just now the question kan tadi kan, U1 tu apa, U2 tu apa. So it is actually one whole length of the winding. In this case, of course, we oversimplify it. We put just one wires. In fact, it could be several hundred wires here, maybe 150, over 150 turns. So when you have more turns, the magnetic field is greater. Now, what does it do? It's actually, it creates a magnet pole. So over here, if you see, the field will will do like this. So if this is the north pole, then
Mm-hmm.
this becomes the south pole, right? And then also on this point, if this is the north pole and then this is the south pole.
I
So in
see.
effect, this is a four pole motor. Why four pole motor? Because it has got four pole. That means two pole pairs. We have got one north south and then another north and south by using one winding.
Mm.
So this one is two pole pairs and then four pole motors. Pole refers to the north and south pole of the magnet.
Mm-hmm.
Okay.
Jadi apa Cik Barin ada yang tanya. So as a rule of thumb dia one set of pole dia is required three status slot lah eh.
Correct. For this four pole motor. No, it requires four lah. Four slots. No, six slot. No, eight slot total.
8 slot total. Oh, okay, alright. Okay, sebab tadi ada
Uh,
soalan tanya, Cik Suhardi tanya, does the number of status slot need to be divided by 3 lah? Sebab dalam
correct.
dekat bahagian atas tu kan ada 3 kan?
Correct. So
Oh,
so this one, what we do is this one is single phase. You know, just one phase. Because in effect we have one phase here,
mhm.
U1 and U2.
Alright.
The other phase is V1 and V2. Now the
Okay.
third phase is actually W1 and W2. So if you put
Okay.
all this winding into the slot, you know, it comes into 24.
Mhm. So maksudnya untuk 3 phase ni memang diperlukan 24 slot lah eh?
No, three phase, four pole motor. It needs 24.
Oh, it needs 24. Okay, faham?
Correct. Yeah. So if a three phase, later we'll see three phase two pole, then you need less slots.
Mhm. Alright.
Okay.
Bari ada orang tanya, Cik Azim tanya, adakah kalau kita rewind old motor ni, dia akan bring back balik the loss of efficient daripada rating plate ataupun better untuk tukar je motor baru, dan apa pro and cons dia kalau kita buat motor rewinding dan include the apa economical punya factor.
Okay. If for example you are talking about efficiency, this is more on how fast you can remove the heat from the motors, right? So it is related to the. You remember when we have um, the AC induction motors that are illustrated blow off. We have got at the back we have got fans, right?
Mm-hmm.
So now if you're talking about efficiency, it has got nothing to do with the rewinding of these motors. It is actually for efficiency. It is how fast you can remove the heat from this stator core into the environment. So how cool your motor can run. So that is more on the efficiency. In terms of rewinding, sometimes people do not want to change the motor because the stator core still can be used. Nothing wrong with the stator core. So the best economical decision is to rewind the motor instead of you buy new, because if you buy new, maybe it takes a longer lead time, and then there are workshops where you can rewind the motor and use it.
Kenapa kita nak rewind the motor kalau what's the purpose of it usually, Barin?
Uh, Sometimes if the lead time is higher, because if you see in shipyard normally we have a workshop called motor workshops, and then it serves the ship's punya requirements. For example, the ship lays on the shipyard, they wanted this shipyard by next month, to sail back, because if they are at the yard, it costs them money, to park the vessel and whatnot. So instead of waiting for new motors, they just can take this motor out and then send to the workshop and do the rewind and then put it back together and sail away. So basically that is the reason lah.
I see. Tapi kalau macam usually what the reason orang untuk tukar motor baru tu?
Tukar motor baru if the stator damage lah. For example, this stator cannot be used. Let's say for example they when they inspect this stator core, they cannot repair it at all because the slot has been broken. For example, so they cannot. It is actually beyond repair. So if things can be repaired, then they can do the rewinding.
I see. Okay, faham. Apa warranty dia sebulan je usually rewinding macam Okay, alright.
Okay, ada soalan tak?
Macam one last question, macam tadi tu, macam contoh daripada slot 7 ke slot 12, dia melalui luar maksudnya?
Ya, dia melalui luar, betul.
Lepas tu macam mana dia to avoid contact with other wire, maksudnya dia insulation ke macam mana?
Okay, remember tadi I cakapkan all this copper winding, it has enamel coated.
Oh, it's already coated.
Yeah, it is been coated by enamel lah. Sana I share my screen sekejap lagi.
Tadi ada satu soalan saya terlepas pandang. Apa ada orang what does this mean by phase loss dalam motor?
Phase loss maksudnya?
Alamak, ini soalan yang ditanya lah.
Kejap, kita go back to this. Okay, this one winding kan? Okay, so this winding is a copper wire, normal copper wire, then they're coated dengan enamel. So that when you turn, there are many turns here kan? If you see, there are many turns. Now, if you turns this, it will, of course, they will touch, right? But with this enamel coated copper wires, it will not be short circuited lah.
Okay, faham.
Otherwise, they will be short circuit.
Alright. Okay, so in term of Q&A, nanti akan ada lagi lah incoming yang baru. So kita continue balik lah.
Okay, kita continue tadi. Let's say, okay, kita go back to, okay, this winding tadi kan. So it is actually I have not talked about this kan. Hold on, let me see. Okay, this one we talk about it. Okay. Now, okay, this is compare tadi tu. Ini adalah two-pole motors. So if two-pole motors, we have one pole pair, right? So we have north and south. For the phase 1, and then for phase 2 as well, we have north and south, and phase 3 north and south. Okay, the operation of the magnetic of the AC induction motor is based on the rotating magnetic field. Tu yang tadi soalan Suhaib kan? How does the motor works kan?
Oh tadi, ada yang ada tanya tadi.
So the motor works by the principle of rotating magnetic field. Maksudnya, bila kita provide power to phase 1 and phase 2, phase 3, then we have a rotating magnetic field.
I see.
I was looking for pointer, sorry, pointer. There's a pointer, okay. Okay, now. Now the phase voltage that we provided here, kan macam tadi tu kan, kita buat winding. From phase 1, it goes inside, and then, you know, it turns. It turns how many times, it depends on the motor lah, kan. And then, on the opposite side, the same phase is winding in the opposite direction. So now we have north pole here and then south pole here. This is another end of the wires or the winding. Same also for the phase 2, it has been shifted 120 degrees, as well as phase 3. Now what will happen is, if you refer to this, from point 1, if you refer to point 1, the phase number 1 is actually at the maximum. So the magnetic field will flow from 1 to 1A. Then the next phase of the supply frequency at point 2, if you see phase number 3 is actually at the negative maximum. Okay, then you follow through at the point 3, 2A and 2, phase 2 will have the maximum magnetic field. So as you go through this three-phase supply system, then you will see that the pole of the magnet have moved 360 degrees. Okay, from here, number 1, number 3, 2A, 1A, 3A, 2, and back to 1. So this is how you achieve a rotating magnetic field. Okay. Now in this picture, it shows it's not a full winding, because there are some slot are still not been put in the winding. So it is a partially complete winding. So far what we have discussed is about the stator. Any questions on the stator?
So far macam belum ada lagi lah. Mungkin lagi ada lah kot.
Okay, belum. Okay, now with the principle of magnetic fields, if you familiar with left hand Fleming rules, if we have current flow in the coils, it will create magnetic field, and then in turn, this interaction will generate force. Force is equivalent to torque. Now for this stator core, there are also force, extracted to this stator core, but since it has been fixed, so it cannot rotate, right? But the force is still there. Now what will happen is, if we put a rotor inside the stator just now, and then we make that this rotor is free to rotate, then with the interaction of the magnetic fields, it will cause the rotor to move. So motor will turn. Okay. The one that we saw just now, this is the stator core, then the rotor is actually inside. When we have magnetic fields, in turn, current will be produced or will be induced. So that is why we call it induction motor, because the magnetic field will induce a current to the rotor, and then when the current flows, it creates magnetic field, and in turn, with the interaction of the bigger magnetic field of the stator, it will start to turn clockwise. So the rotor here is also having a winding in terms of rotor bar hopper, so that it can flow, the current can flow easily, as well as there is a magnetic field created by the current flow, and in turn, this will cause the force exerted on the rotor. Since the rotor is free to move, it will rotate. Now, if you see this, the left-hand Fleming rule, when we have current that flows inside this rotor bar, it will create magnetic field. Now, when the magnetic field interact with the stator, it will create a force. So that is the reason why the AC induction motor is called induction motors, and then it will cause the rotor to turn, so that we can have rotating force that could be used for process pumps and compressor.
Ada yang bertanya, Cik Amir tanya, kalau dekat dalam stator core tu, kalau dia macam patah ke broken, so looks like kita mungkin akan kehilangan one phase of it. And is it the motor still can run? And if can run, how can we detect that?
Okay, if the state rotor rotor bar here patah kan?
Tadi soalan dia motor stator.
Oh, stator side.
Stator side yang tadi tu.
Hold on lah, we go to stator side here. Yeah.
Mungkin kalau on the one phase punya, mungkin kan ada 3 phase. So if one tu dia broken, so is it will cause is it the motor still can run?
No, tak boleh sebab dia dah jadi tak balance tau. Sebab rotor may touch this stator core.
I see. Maksud
the reason why broken of this core is because maybe the bearing give way, and then the rotor will hit the stator core inside, and then it breaks. So once that situation occurs, then you cannot run the motor at all.
So looks like maybe vibration akan tinggi lah kot kalau ada tanda-tanda tu.
Yeah. No, vibration comes first. Vibration comes first because of maybe bearing give way, then it causes vibration, and then if we don't look at it, then that vibration causes the rotor to slam into this rotor bar, right? Or the stator bar, and then it breaks. So now we have dire situations since we have not looked at the bearing punya issues, and then it escalates into this. But given the fact that once you put this together and then the bearings are okay, then it is unlikely that you can damage the stator core, unless short circuit. Maybe because you run this motor with a very low airflow, and then the rotor becomes very hot, then the insulation inside the white element that we saw just now give way, and then it touches the core, then it burns. So that also can be the possible cause without having this bearing slam into the stator core. If the bearing slam on the stator core, it is very severe damage. So nothing can be done. So you have to take it and then replace the motor.
Usually apa simptom yang ada Bahrain kalau prior this thing to be happen?
No, actually, you need to check on the bearing side, man. You need to check on the whether the vibration is high or not. Then you check also on the displacement of the air gap. You know, between the stator and rotor, there's a air gap in between. So now, if you take, for example, this year you take there are certain air gap, right? Then maybe next month you see that the air gap is actually it's not um, uniform. So this side is actually there are more gap than the other side. So you know that there is something problem with the bearings. So from there you have to take the actions, and rather than you leave it there, then you will migrate into other issues, like we discussed before.
All right.
So
Okay.
I will discuss this later in this training at the back when we are touching about the maintenance of the motors. Okay.
All right. Perfect.
Okay. Now the principle of um, AC induction motor is understood or not on how we generate the rotating magnetic field, and then why this rotating magnetic field cause the motor to turn. You know. So the general idea is there. Everybody understand? Because that is the the what call it the the objective of it. Once you understand that, then everything else is secondary. One
Correct.
you need to understand is actually rotating magnetic field. Rotating magnetic field is coming from the power supply that we get from the grid or from the generator, and then that rotating magnetic field will interact with the rotor magnetic field, and then it causes force to be exerted on the rotor, and it turns the whole thing, the motor. If you
Yeah.
understand that, then it should be okay. Then the rest, we just is just secondary. So make sure you understand this.
Mm-hmm.
If you have any question, you can ask.
Ya, Cik
Before we
Suhaidi,
move,
teruskan.
hmm.
Kita
I
ada
have a
question.
question for Encik Baharin. So the stator, as you stated, is a coil as well, lah. It's not a permanent magnet. Yeah, that is my question. Is the stator a coil winding as well or a permanent magnet?
The stator core is actually metal.
Sorry, rotor. I
Oh,
want
rotor.
rotor. Yeah, the rotor is a winding as well, or a permanent magnet.
No, the rotor is winding as well, because if you
I
see this,
see.
this is a rotor bar.
Okay, all right.
Mm-hmm.
So the number of slots and everything is also similar, reflecting to the status side. Is it duplicating the status side or?
Yes, definitely, because over on the other side it has got 24 slots.
Uh-huh.
That means on this side also 24 slots,
I see.
because
Okay.
it has to be aligned, with the
Mm.
stator magnetic field.
Okay. Okay. Understand.
Okay.
Thank you.
All right.
Alright, thank you Cik Suhaidi for the question. Right, Cik Baharin, kita boleh continue.
Okay, kita continue. So that's about it lah. In terms of AC induction motor. Now for electrical, we have this schematic where we represent the AC induction motors. Just now you saw that you have U1, which is one end of the wires, and then U2 over here, V1 and V2, W1 and W2. Now if we short this together, uh, U2, V2, and W2, it will become a star connected motor. Okay. Now, how the delta connection is made? Anybody can guess? we have situation where the motor, since the two windings that has been brought out, for example, if you see this is actually the terminal of the motors. U1 at one end and U2 at the other end is brought out. This is the actually the interface with users, whether they are going to control it using DOL, and then it is star connected, or they are going to use star delta connection. So it gives you the flexibility to connect the motors in which way you are designed for. Okay. Now the question is how the delta connection is made. Ada nak jawab kah?
Ada yang jawab triangle jawapan dia.
Triangle, okay.
Triangle connection. Macam tu lah jawapan dia.
Triangle connection, tapi in relation to this what call that connection tadi tu. How do we do?
Belum ada jawapan lagi.
Belum ada jawapan lah. Then I'll hold on sekejap lah. Just now we have this, right? U1, U2, V1, V2, W1, W2, right? Now, if we have U1, V1, W1, W2, U2, V2. Now they are purposely, instead of U1 and U2 over here, they are putting U2 in the middle. There is a reason for it. Okay. Now, if we were to connect the motors in star, like shown in the slide just now, we just connect this together. That means we short circuit this, right? Now, let's say we are going to connect this in delta. How are we going to do this? So in delta connection, what we'll do is we connect U2 to V1 and V2 to W1 and U1 to W2. So by looking at this, instead of you are connecting this in star, in delta you are going to connect U1 to W2, V1 to U2, and W1 to V2.
Baru ada yang
So
tanya soalan. Oh, sorry. Nak habiskan dulu, habiskan.
Okay, so this is the delta connection. Okay.
Ada yang bertanya macam mana kita nak pilih star ataupun delta.
Okay. This is more on electrical questions lah. Disebabkan we have three phase. If we connect in star, our V phase is actually V line divided by square root 3. If we have in delta, V phase equals to V line. Okay. Now, I delete this one. So this one become delta connection. Now for Y, current, phase current is equals to line current. Just bear with me first, then I'll explain to you what does it mean. Then I phase is equals to I line divided by square root 3. Now, when you have DOL, you are connected the motors in star. So the phase voltage is actually this one, right? The phase voltage is actually V line divided by square root 3. That means you are starting at reduced voltage, right? Now, if you are having star delta connection, when you start the motors, you are using star, and then when you run it, you got the full voltage, but the current is lower. Okay, so that is why in some cases to start the motor we use star delta connection. This is to take the advantage of during starting we have uh, lower voltage. Then when it runs in delta with lower current. This lower current is actually the rated current. Okay. Apa soalan tadi? Sorry?
Ada yang tanya macam mana kita nak choose star atau delta ataupun star delta ni just a starter je lah yang maksudnya.
Yes, normally motors vendor will give you the choice, the ability to use delta or star. But now you have to go and see what is the advantage of connected in star, and then what is the advantage of connected in delta. Like I said just now, if putting in star, that means your phase the phase voltage is actually V line divided by square root 3. So that is the voltage. You have got a reduced voltage during starting, right? Then when it runs, the current will be the same as the rated current. So in effect, some of the motors they are connected in delta, some of the motors they are connected in star.
Ada application yang perlukan dua-dua?
Untuk starting
Just
for example, just for starting because you want to take the advantage of having lower starting voltage.
Alright, faham?
Okay.
Usually macam mana in term of configuration dekat waktu installation untuk dia ada shifting tu from star to delta, Cik Farid?
Dia akan pakai contactor. Dia tadi tu kita kena keluarkan semua connection ni, then kejap I delete this. Okay. Now if your motor is in star, inside this terminal box, you're going to short this. Okay, and then that's it. This is inside, right? Now, if you have delta, you have to connect this like this, right? So that's it. Now, when you have star delta, you have to bring all this connection out. Sorry. So instead of you're supplying this, the voltage here, you're going to take this out to the controller in the switch gear. So now instead of you are having 3 core cables, now you have to have six core cables, and then this will go inside your MCC. Inside this MCC, there are contactors that when starting, it connects the motor in star. Then when it runs, it shifts to delta. It uses contactors plus timer. For example, when you start, after a certain period of time, after a few seconds, then you switch to delta. This being done, this type of starter is being done to reduce the starting current of the motor.
Alright. So rasanya Cik Amin rasa benda ni menjawab lah soalan awak. Dan untuk ada additional question Cik Warin, Cik Warin boleh bagi example tak macam common practice dalam industri, which one yang kita guna untuk star connection dan which one kita guna untuk delta connection, which one yang kita akan guna for both application. Macam both application macam dah contoh yang ni lah, tapi dalam industri application dekat mana dia akan guna this time of configuration sama ada
tadi
combine.
Tadi kita dah discusskan the reason why kita pakai star delta is to reduce the starting current. Now if you go economically wise, DOL is the straightforward punya starting configuration. Although dia straightforward, tapi dia jadi the starting current is high. It could be 6 times full load current or 7 times full load current, right? If your system, that is why I said just now from the beginning, responsibility of electrical engineer to ensure that the motors that you have in the plant should work regardless whatever situation. So we need to do the studies. So when we do the network studies, we see that when we start the motors in DOL, which is the cheapest control scheme, it gives a very low voltage dip in the system. So bila dia jadi voltage drop tu, then they akan affect semua running motors. So kita akan ada issue on that. Then they go, once that issues crop up, then they will look into several solution. One is maybe you are using auto transformer. It could be also, but auto transformer, it requires area, area to put in, where to put in the transformers and everything. Then the panel will become bigger. Then you go for another solution, maybe star delta. Star delta, it requires a bigger controller than DOL, tapi it is much smaller than auto transformer. So maybe they go for star delta. But star delta, like I said just now, instead of having 3 wires that goes into the motors, now we have to bring out 6 wires that goes into the star delta controller. Okay. The next one is the if star delta is not viable, then we need to go for soft starter. Soft starter is expensive. Then on the higher side will be VFD lah. So if you go for VFD, it's more expensive. So it is actually the choice of power system engineers to run this, and then to make sure that when you start these motors with huge starting current, it will not affect the other items online. For example, if other motors is running, when you have a voltage dip, then the current will increase because of the running motors need the power,
Mm-hmm.
to maintain its process parameters. So when it goes up in current, then further voltage drop will occur. Then it may cause the total power failure. So those are the studies that electrical engineers need to do to decide whether we are going to go for simple method DOL, very cheap, very easy, or we go for a little bit higher solutions, star delta or auto trans, or in fact, if a process needed, then we may go for VFD.
Alright. Thanks for that.
Okay.
I guess macam ada one of the question tanya pasal self starter, so you already mentioned just now lah. So dia configuration jugalah, what type of configuration juga on the combination of star delta eh?
Dia it is more on electronics, power electronics. Sebab
Mhm.
kalau kita tadi kita ada try star delta pun tak boleh, still voltage drop very high. Then we go auto transformer pun tak boleh, still very high. Then the next step is kita go for soft starter. Soft starter ni dia akan dia macam VFD juga, tapi dia on the lower side lah. So kita boleh set starting current maybe dalam 3 times or 300% of a full load current. Tapi VFD is 100% saja kan starting current.
Alright. Baik, faham. Jadi macam regarding kita faham tadi kan dia punya voltage and current tu berbeza. So usually kalau dalam nameplate tu, is it the written one is what is the nameplate punya kita panggil apa, the current required tu?
That is the rated. On the
Rated,
nameplate is actually the rated, yeah.
rated tu dia refer to apa? Is it the delta ataupun starting point tu, is it dia consider ke tak? Yang macam
Tak.
tak.
Itu dia consider apa tu power. For example, if I rated, right, if the motor is 110 kV kilowatt, then you divide by square root 3, then you times the voltage, then you times the power factor and efficiency. So this is the rated. So if you see this over here, regardless whether you are connecting star or delta, this factor square root 3 is there. So
Alright.
regardless whether you are connected in star or delta, the rated current is the same. Right?
Alright. And then continue on the question. Dia tanya, so does the motor only run with that RPM or that kilowatt only at startup lah eh? Kaya during operation, what will be the RPM and the kilowatt itself?
Okay. Sekejap ni I delete sekejap If we have a motor, the RPM, this one actually we have a slide on this, tapi tak apa, since the tanya, then I go ahead lah. We have got RPM here. RPM is related to the frequency of the supply. So the maximum, the frequency, for example, if your grid is 50 hertz, that means it can goes up until 50 hertz, or 60 hertz, then it can go up until 60 hertz. Okay. Now, for the RPM, it depends on the pole. Pole just now we saw, right? Pole. If we have 4-pole machine, if we have a 4-pole machine, then the RPM will be 120, for example, 50 or 60, then divided by the pole. which is, oh tak ada calculator lah, sekejap.
Oh,
Let's say for example 50
mhm.
divided by 4. Okay. Now 1500 RPM or 1800 RPM. So this is the synchronous speed. Synchronous speed. For AC induction motor, it will run less than this speed. For example, it will run 1497 RPM or maybe 1797 RPM. Because for AC induction motor, it cannot run on the synchronous speed since you cannot align the magnet right together with the stator. So the rotor will turn a little bit slower. Otherwise, the rotor cannot rotate if they are on the sync together. So the synchronous speed is actually the speed from the supply. For example, 50 Hz or 60 Hz. Now for the induction motor, that will reduce to the factor that we call sleep. We will see later what is sleep, why the sleep occurs.
Alright, baik.
Okay.
One last question regarding on this. Is it possible to have VFD and star delta together for one single motor?
Soalan dia macam it is not possible to connect them together lah.
Okay, baik.
Sekejap. Now, if you have motors here, you are going to connect your VFD here, right? Now, imagine that, the question just now, motors, how are you going to connect star delta and VFD together? So it's not possible, right? Because the connection over here, the interface to the motor is actually one only. So you have to connect either to the star delta. Now this requires 6. But for VFD, we require only 3 connections. That means U1, V1, and W1. Okay, hope that answered the question.
Alright. And regarding on the frequency just now and the RPM, Cik Warin, ada yang bertanya lah, sometime I see the nameplate motor rated 50 or 60 Hz, but in VFD someone said it to run at 100 Hz. Is it, can the motor actually run beyond the 60 Hz? Beyond the rated?
In fact, let me see. I buat baru lah. What I understand, this is related to mechanical punya ni kan, punya limitation. What I understand is VFD works in principle of V over F. Limitation that VFD have is actually the voltage here. For example, this voltage is for voltage for the motors, let's say 11 kV. Right? Now the frequency it can go higher. I think in API or something, can't remember. At least 5% running over the frequency. That means this is a linear V over F. When it comes to the limitation of the voltage, it can goes up until 5% of the frequency. For example, if this is 60 hertz or 50 hertz, then this one is 1.05 or the factor. It cannot go beyond. Okay. Number one, because of the rated voltage of the motors, so you cannot go higher. Number two, the supply frequency is actually limited to 60 or 50 hertz. So it cannot goes to more than 100. 100 hertz, yeah. But mechanically, you can couple it to gear or whatever mechanical, then you can go higher RPM. But as long as far as electrical is concerned, based on the voltage and frequency, so this is the limit. We have got the limitation in terms of voltage supply and also on the frequency supply of the network.
Okay. Okay. Maybe we continue back with the slide. Kampung kita dah already 11:20.
Itulah, dah lewat dah.
The Q&A is really exciting. That's the reason.
Okay. Okay, so we understand now how to do the connection in Delta. So we saw also 4-pole motor. How does the 4-pole motor is generated using the same phase? We turn the winding in the opposite direction. Then you can have a pole. So this is the formula that we discussed just now on the RPM side. This is the synchronous machine.
Cik Baharin, slide kena share balik. Slide kena share balik.
Oh, tak share.
Ada.
Kau dah share slide. Sekejap. Okay. Nampak? Cik? Hello?
Nampak.
Okay. So this is the synchronous speed that we discussed just now. If 50 hertz, then we have 1,500. If 60 hertz, then we have 1,800. Then induction motor have sleep. When we have sleep, then the motor will turn at the lower rate than the synchronous speed. Okay. So this shows the insulation of the motors, the white material that we saw in the beginning. And also for the motors, we have a temperature class and insulation class and temperature rise. We can have insulation class F and temperature rise class B, or we can have insulation class H and temperature rise class F. Okay, this is related to the amount of heat generated inside the motors, which needs to be taken out by the ventilations. And also we have thermal protection inside the motors. We have winding temperature detectors. And then for induction motors also we have three types of bearing: roller, ball, and sleeve bearing. In the next slide, this is the sleeve bearing for the HV motors. And also we need to look into data sheets of the motors, see the efficiency, power factor, service factor, and voltage. And then for the efficiency, we need to remove the losses in terms of heat effectively using fans that is driven by the shaft of the motors or external fan, depending on the design. And then the motor also need to be designed for its installation. For example, in zone 1 and zone 2, we can use EXD motors. In zone 2, we can use EXNA motors. Or if not, then we can use EXP motors in zone 1 and zone 2. So the choice is, depending on the economic factors and the where the motors are going to be installed. So this explains the difference between the motors with PERT, PX, PY, and PZ. A little bit about the zone. Zone 0, where we need to use IS circuits or equipment. And zone 2, we need to use EXD, and as an option, we can use EXP as well. And for that is for the zone 1. Then for the zone 2, we can use EXNA. This is the motto for the increased safety, which is suitable for zone 1 and zone 2. But this is a very expensive motors. Normally, we don't use EXE motors. Now, motors also are related to its IP rating. Normally, on the main deck, we use IP56. And this shows the cooling method, whether we are going to have self recirculation or we have forced circulation using external fans. So this is the interface that we have with AC induction motors, the terminal box. So this is where we connect so this is where we connect we short the terminals for the Y connected motors. This one will go to the supply side. Now for Delta, we have seen that it is connected directly instead of we are shorting this terminal. This is another terminal box for HV motor. And then when you assemble all these LV motors, this is how it looks like. Then we send this motor for the testing. There are 3 types of testing. The routine test, type test, and special test. Some of these, normally these tests are applicable for the custom-made motors. But for the LV motors, is normally a standard motor, so we don't need to go through this because it's already been type tested. Only the HV motors, where we need to design for it, then we need to test. So this is an example of a real project that I've done. This is EXNA motors. This IP rating of 5.6. And then this is a 6.16 cooling method. And then we have separate fans mounted on the cooler. This is EXD motors, where explosion will occur inside the motors, and it will not propagate outside its enclosure. This is another project that I made, EXPX, with IP56 and IC611. Now, since we have EXP, that means this motor is pressurized. We have a control unit here for system. And then also we have the purging flange for the connection to the instrument air. The other important part is actually the motor key, where this is connected to the pumps and motor shaft, so that it can be rotated together. We are talking about the vibration just now. So this is how the vibration is being measured using proximity probes mounted on the x-axis and y-axis. So it can measure the how what is the situation in terms of shaft vibration. In terms of maintenance, motor maintenance, you need to lubricate the bearing, and then also checking the bearing free play, whether it can, and also on the air gap that I've discussed just now. If there is a runaway in terms of air gap, that means it is indicative that the bearing have some failures. It may give way, and then the rotor may wrap the stator core, so it causes more problem. So for the maintenance guy, you need to ensure that the bearings are checked regularly. So this is what I'm talking about on the air gap. It should be measured. For the belt mounting motors, belt driven motors, we need also to check the belt tension as a part of motor maintenance. Over here, we have seen that the pumps and motors are mounted together in one common mounting. So this need to be checked also to avoid any vibration by the driving machine. Also, you need to clean the motors. Don't leave it like this; it's so dirty. And then the rate of expulsion of heat from this fin also will be affected because of the dust accumulated on the fin of the motors. And also you need to keep records in terms of its installation test, and then examine the trend. And not only the motor itself, you need to also concentrate on the motor control center for the maintenance. You clean all this dust that accumulated in the contactor or MCCD. And then check also operation of the contactors. Make sure that the solenoids for this contactor is working fine. Occasionally or regularly check this, for the good contact. And also some of the settings are made during engineering stage, and then this needs to be checked for proper setting, because sometimes people, we do not know that they change the setting without giving the without asking whether it can be changed or not. So this needs to be checked regularly as well. We have seen the motor starters just now. DOL, this is a very simple motor starters. So this is the circuit that I wanted to discuss. In terms of control, it is straight away. We have one line control here. Then when we start the motor, this the main contactor KM will get energized. Then in turn, this contactor of KM will close the contact, and the power flows into the motors and it runs. Now when we stop the motors, we just press this button, and this is a normally closed circuit. When it opens, it takes out the power to the main contactor, and this opens. So this is very simple method of starting the motors. When we have issues in terms of thermal overload, this motor is been blocked, or the loads are stuck, then thermal overload will operate. This will open this thermal overload relay, and then the red flag will light up, showing that to the operators that you need to attend to this motor since there is a overload on this motor. This is a star delta. Like I told you just now, we have several contactors for the star and delta. Now, if you notice that there are, like I told you, there are 6 cables that need to be brought out from the motors instead of we saw for the DOL just now. This is only 3. Now for the star delta, we need to take out this connection so that we are able to connect the motors during starting with star, and after it runs, it needs to be connected to delta using timers. Now for the auto transformers, it's also based on a principle of reduced voltage. So it will have some certain taps. When we start, the step is lower, so lower voltage it goes to motors, and then as we are running, then the tap will go up accordingly to the design. Now this is the soft starter. Also, we have got three connections to the soft starter. We can run this soft starter using the power electronics that it provides. Now, in terms of solid state VFD, we also have 3 winding connected to the VFDs, and then from here we can set the the frequency, the setting, the running of the motors accordingly. Okay, this is very fast. I don't know, it's about 11:30 already. So this is my live slide. So thank you for your attention.
Alright. Thank you,
So
Cik.
very fast.
Still ada some of the Q&A remaining sikit. I guess we can go through on that. So, one of the question yang ditanya adalah Cik Azim have seen that their motor already equipped with VFD tapi still need a gearbox and it operate at low frequency like 8 Hz or 15 Hz, something like that. And he believed that VFD can simply reduce the speed without the gearbox. And what your opinion about that, Cik Barin?
Okay, VFD design ni dia akan related dengan apa tu motors juga, tapi in this case it is more on the lower frequency. When we design the VFD motors, we need to design the motors that have certain margin in terms of its critical speed. So that is more on the higher side of the RPM. So now in this case, maybe when they do the, all these things come from processor kan. So process, when they define it, they have a certain range of frequency or speed that they wanted, then maybe when it was designed, but I don't understand, why it goes down to 8 Hz, because this VFD can do that. It can start from 0 up to before the critical speed of the motor. So I think VFD can do that, from 0 to whatever maximum that we can go.
Alright, perfect on that. And regarding on the connection, so Encik Amel interested to know in terms of the common connection in the panel for motor start from power supply. So how the connection, I guess just now you also show kan macam motor is the final element, but before that macam mana dia punya daripada power supply dia ada MCB ke ELCB ke, is it have something like that?
Sekejap saya screen balik. This one kan?
Maybe some sort like this.
Okay. For the protection, we have protection for the short circuit. Short circuit is covered by circuit breakers. So this could be MCCB, kan? Then for the thermal overload, it will be under this relay lah, thermal overload relay. So kalau berlaku anything on the load side, so it will lock the rotor from turning. Since dia dah lock, then dia akan increase in heat. So bila dia increase in heat, thermal overload ni akan operate. So without the circuit breaker tripping. But if there is a fault on the cable itself, goes to the motor, the current will be higher. Remember just now there are difference. One is the heat, the other one is the current. So when the current is higher, this one will not trip, but the circuit breaker will trip. Because this circuit breaker is designed for the short circuit rather than overload. So there are two coordination between the thermal overload and MCCB. So it has to be separated. One cannot do the job of the other. Yeah, correct.
Kalau this one is talking about power, tapi macam contoh kalau dia ada VFD ke apa, so dia mesti ada some sort like another supporting system macam dia ada PLC atau IMCS. So this one ni dia tie in dekat mana Cik Barin?
Kalau VFD?
Kalau contohlah kalau VFD lah.
Kalau VFD dia still
ataupun daripada main control room daripada DCS tu sendiri, dekat mana dia connected daripada software DCS instrument tu untuk hidupkan motor ataupun untuk regulate dia punya speed lah apa semua tu.
Okay. For electrical side, dia akan ada macam ni lah. Ini kan betul lah. Ni nampak VFD kan?
Contoh VFD lah.
Tak, ni nampak di VFD ke apa?
Macam soalan ni dia tak bagi tahu lah, tapi saya just give an example lah. Kalau VFD
tak bukan. Yang saya share ni VFD ke DOL ya?
Oh, VFD.
Okay, dia okay.
Okay.
So, yang ni tak bergerak ni tadi. Okay. So kita ada VFD kat sini. So connection untuk electrical adalah L1, L2, L3. So after that L1, L2 ni dia akan ada circuit breaker lah. Of course dia untuk protect from short circuit. Okay. Short circuit lah, tak ada masuk overload. Yang tadi tu ada overload kan? Ni tak ada overload. So sekarang ni daripada VFD ni dia akan connect to the motor directly. So dalam ni dia akan measure all the parameters that is related to overloading in terms of temperature dan semua protection for the motors lah. And then from this VFD juga dia akan connect ke DCS. Dia akan connect ke DCS untuk control the VFD to run at a certain set point. So all interface are all here.
Alright, baik, faham. Dan dia punya macam tadi ada thermal apa semua tu dia akan duduk bahagian mana kalau dekat sini?
Dekat sini dia duduk dalam VFD tu itself.
Oh, I see. Dia part of the package semua sekali lah dalam tu kan?
Semua sekali dalam tu. So dia akan protect the motors. Sebab dia boleh measure tau. Dalam VFD ni dia boleh measure current, voltage dengan power. So daripada situ dia buat deduction, kan? Dia buat calculation dia. And then dia akan ada winding temperature juga akan masuk ke dalam VFD ni dan dia akan measure dia punya overloading lah.
Alright, baik, faham. On the next question ada tanya, how to determine rotation of motor from the terminal connection?
How to determine, you just connect this one. Let me go back to normally during sebelum kita buat solo run, kita buat this test as well tau. For example this one kan.
Yang ni, okay, ada table. Alamak. Oh, this one.
Nampak?
Okay, ada terminal punya gambar.
Terminal punya gambar kan. So sekarang ni kalau kita connect U1 ni to face red, yellow, blue, then it turns clockwise lah katakan kan. Then if we move this if we switch over, one of the terminal, then it may turn the other way around lah. So we need to look at the data sheets whether this motor should turn clockwise from drive end ataupun anti-clockwise view from drive end. So you need to make sure it is correct because sometimes it happens that the motor turn in reverse direction, so it defeat the purpose. So this is part of commissioning check.
Alright, thank you for that. So I guess in term of question regarding this part ni dah tak ada lah from the chat box. That's what can I see. So mungkin sebagai penutup Q&A, dia soalan cuba emas sikit lah kat Cik Bara. Berkenaan kipas ceiling di rumah, comparison penjimatan guna AC ceiling ataupun DC ceiling fan. Kita closure dengan soalan cuba emas sikit.
Macam mana?
Untuk kipas di rumah, yang mana lebih jimat, yang AC ke ataupun DC fan?
DC fan DC fan ataupun AC fan? No, actually dia konsep macam ni tau. Kalau equipment tu ada stiker apa tu, energy efficient tu, itu dah jimat lah. Macam contohnya aircon is more appropriate lah untuk kita punya example. Rather than ceiling fan kan, ceiling fan ni macam kecil sikit lah. So aircon, if you go for inverter, it's much better than normal punya aircon lah. Sebab kalau inverter dia akan ada set point dia, bila kompresor tu akan kicks in. Kan? Kalau macam contohnya kalau dah panas, then kompresor kicks in. Tapi dia tak kicks in 200%. Normal punya aircon, bila dia kicks in, dia akan kicks in 100% terus. Kan? So we are wasting energy in that sense lah.
Alright. Okay. So thanks for the wrap up punya question. Alright, jadi there are another question mengenai deck ni. I guess for sure kita akan share Cik Barin to the participant afterward.
Apa dah? Slide back. Boleh, no problem.
Alright, baik. Okay, kalau macam tu maybe I open last one lah kalau ada question from the participant kalau ada. It's already 11:45 but it's okay, I open for the last one. There's just one comment from the last question just now regarding on the terminal and the rotation of the motor. Dia tanya soalan tu disebabkan dia ada jumpa banyak case yang wrong direction punya pasal yang lead to mechanical seal damage. Tapi disebabkan oleh terminal punya salah tie-in lah.
Salah ni lah, salah connection lah kan.
Connection.
Itu lah. Kita selalunya kan, from what I experience lah, kita ada regime tau, bila kita dah buat engineering, then kita go to construction, and then before starting ada dia punya program tau. Contohnya kita buat soloran kan. Lepas tu bila soloran tu kita tengok pula motor tu pusing ke mana kan. So all those regime is there tau. So I tak nampak macam benda tu bila dah operate akan terjadi. Mungkin masa dia orang change the motors maybe lah kan. Tapi from if a greenfield punya project, susah lah nak jumpa macam tu kalau dia go through the regime. Otherwise kalau benda tu dia just buat hanky-panky, kalau maybe that is the problem lah.
Understood. Alright, so thanks for that last question. So I guess we already come to the end of session. So first, we would like to thanks lah to Cik Bahrain for your time and your expertise sharing on this. It's a really new thing lah. Even for myself, tak pernah pun tengok detail of kind of pasal alam motor tu sendiri lah. Usually tahu RPM je dengan berapa temperature dia, vibration itu je yang tengok as operation lah. Jadi that's in term of that. We would like to thanks for you, and then maybe afterwards, Cik Baring, do you mind if kalau ada any question from the participant, they can reach you out as well through LinkedIn juga boleh, Cik Baring?
Hey, no problem. Anytime, yeah. I
Alright.
also wanted to say thank you for everybody for attending this training. I apologize for the hiccups, because first time I'm using Click Meeting ni kan, tak tahu dia punya ni, so nasib baik ada ada IT yang tolong kan, kalau tak ada susah juga kan. So adalah delay sikit, sorry for that. Then hopefully you learn something lah kan. If anything, then you can reach me through my LinkedIn. No problem.
For sure, and I really encourage all the participant to follow IR Barin Cik dekat LinkedIn, and also Engineer Digest jugalah. And yep, I think yeah, everyone is thanks to you, Cik Barin. And alang-alang tu ada one small question mungkin dia baru teringat. I guess mungkin Cik Barin just can answer lah. Is it recommended untuk kita cat the old motor? Is it will impact on the heat transfer tak?
Oh, motor memang kena cat pun kan, sebab itu part of protection kan, corrosion protection. Tapi kalau you tengok dekat motor tu, dia akan ada fin dia kan, untuk engine motor lah. Dia akan ada fin. So fin tu yang kita kena make sure that it is clean, so that the heat transfer can occur.
Alright, okay. Thanks for that. So I guess maybe that's all for this session. So kalau yang belum lagi isi your